Okay, this is a continuation of the review for sections 2.1 through 2.7, Algebra 2 and Honors Algebra 2. And we're on example Q. What we have in this example is a picture of a parabola that crosses the x-axis, and we're asked for the positive and negative intervals in interval notation. So try your hand at this first, and I'll move on to the solution here. Okay, you find the two intersection points, -9, 0, and 4, 0 in this case. And then you look for, let's do the negative interval first since it's the easiest. You find a section that's under the x-axis, and those are the ones that are described as points on the parabola where the y value is negative or downwards. And then you have to switch gears. The answer is actually not a y value. It's the starting left-hand x value and the ending x value described in interval notation. Now let me describe why we use round parentheses on this instead of the square ones. This point over here will serve for me to illustrate this. The reason we have this open bracket here, a round bracket, is because at that point, the y value, and I'll highlight it there, is actually not a negative number. It's 0, which is neutral. So you don't include the endpoints on this. All right, so let me back up a bit, and now let's concentrate on the positive intervals. Well, there's an interval right here where all of the y values are positive, since to get to those points, you would have to go to the left and up. It's the up part that makes it a positive interval. The other place that's above the x-axis is over here, so just describe these one at a time. On the left-hand side, we have one that starts over here at -infinity. That would be the furthest to the right, furthest to the left. Forever to the left until you, as you go from left to right, get to the -9 value. So this is the starting and ending x value. From forever to the left until you get to -9. And on the other side, it's from 4 and then forever to the right. Going to the right in the x direction is a positive infinity. Okay, so here's R. It's the same type of problem, except now you have to come up with your own picture. So try your hand at this and then hit play when you're ready to look at the solution. Okay, so let me describe what I'm doing here. You're looking, first of all, for the zeros of the function, which means what makes the y value turn into 0. Eventually, we're going to find those two locations there. And let me point out that this is the x-axis here. Okay, so what we have here is a function without a GCF, and you just simply break it open using the star. And once you've got that work done, you see how it factors. And you set those factors equal to 0, which leads you to -3/4 and 1/2. And that's how you get those cutoff points on the x-axis. They're called zeros. It's the x-intercepts. The graph crosses there. Okay, now I'm going to point out another key thing you need to realize. Since the value of a, in this case 8, is positive, you want this parabola to go upwards. Sometimes you'll get a negative number up there. Well, instead of that 8, if it was -3, for instance, the graph would bend downwards like that. Okay, and then you just go through the process of finding out where it's below the x-axis, from -3/4 on the left to 1/2 on the right, to where it's above the x-axis, and that would be from -infinity on the left to -3/4 on the right. And the other one is over here, starting at 1/2 and going forever to the right. Okay, S, T, and U, the instructions tell you to solve for x using the square root method. Okay, I'll walk you through all three of these here. First, you subtract 7, gives you negative 96. Then you isolate the x squared by dividing away the negative 4. And that takes you down to 24 down here. Then you take the square root of both sides, and don't forget that there's two square roots, the positive one and the negative one. So then I split apart the 24, and you'll notice I used 4 and 6 instead of, say, 2 times 12. And that's because we want a perfect square, in this case 4. The square root of 4 comes out as 2, and you get both answers, positive 2 root 6 and negative 2 root 6. Okay, example T, subtract 3 off both sides. That's where the 36 comes from. Then you square root both sides. Once again, when you do that, you have to remember that plus and minus sign. The square root of 36 is 6, so we get positive 6 and negative 6. Take your 5 over the other side. And first you add 6 to get 11. Sorry, negative 6 plus 6 gives 1. And then you subtract 6 to get negative 11. So there's your two answers. Okay, on example U, I first start by subtracting 5 off both sides. That's where this negative 18 comes from. And then I multiply by the reciprocal of 3 halves, which is 2/3. When you do that, you cancel here, and you just get x squared. On the other side, if you have trouble multiplying a whole number times a fraction, divide first. Negative 18 divided by 3 is negative 6. Times 2 gives negative 12. And you square root both sides. This negative is going to come out as I. Split up the 12, and that root 4 becomes 2. So your answer is positive and negative 2i root 3. Okay, here's a skill that is going to be only on, well, this skill here is only on Algebra 2 Honors this year in 2022. However, I'm going to have to give you guys a guide to which problems are in which course. So I'll address that separately in a separate document. Okay, pause and see if you can complete the square to solve this one. Okay, I think I'm going to take you from top down on this one. So let me erase everything that's here. Take you through it step by step here. All right. First thing you got to do is make sure you end up with a 1 in front of the x squared. So you got to divide everything here by 5. So that takes you to 1x squared. That was your goal, by the way, minus 6x. And plus 11 equals 0. Now you want to get this constant out of the way, off to the side. Don't want that there, so I'm going to just put a blank where that 11 used to be, and now we got a negative 11 on the other side. Now we're going to add something in that blank, and you got to balance it. So I'm going to put the same blank on both sides. You take your middle number here when you do this, negative 6, cut it in half. That would be negative 3, and square it, and that'll give you positive 9. That's your magic number here that makes the whole left side work. Okay, so now what you have is a perfect square on the left, x times x at the front. Minus 3 and minus 3 is how you finish that. And over on the other side, negative 2. So you got x minus 3 squared, and on the other side, negative 2. Okay, now you got to take the square root of both sides. Don't forget the plus and minus sign when you do that. The left side ends up being just x minus 3, since the squared got reversed. And we're going to have plus and minus I root 2. The I comes from that negative that was under the square root sign. Okay, we got one step left. You're going to take the 3 over the other side and put it in front of the plus and minus sign here. So here's your two answers, 3 plus and 3 minus I root 2. So those are your answers. Okay, on this last pair here, I'm going to go ahead and do these two. You've got the quadratic formula in play here. And the first thing we want to do here is, well, I'll let you pause it and try it yourself first. Okay, so let me take you through what I did here. I distribute it here. That's 2x squared. Then I multiplied here, and that gives 5x. And I brought the 3 over. And when you do that, you've got it in standard form. It does have to say equals 0 for that to be true. And the formula, let me write that off to the side, is x equals the opposite of b plus or minus the square root of b squared minus 4ac over 2a. Excuse me. So you start with the opposite of b. You can see I changed the sign of that middle term. Then you square that. Please note that you'll always have a positive number there when you square the b value. And then you go minus 4. That's a permanent part of the equation. You can see it up there. And you multiply that by the a and by the c. And you put that over 2 times the a value. If you simplify the bottom in your head, 2 times 2, and type that discriminant part, it's called on your calculator, so 25 minus 4 times 2 times negative 3, it ends up being 49 under there. That's called the discriminant. And then you take the square root of 49, which gives 7. And then these two answers, one comes from using the plus sign and the other from the minus sign. So for instance, negative 5 plus 7 over 4 would be 2 over 4, which is 1/2. And then subtracting gives you the other answer. Okay, so I basically did the same thing on this other side over here. I brought it over and put it in standard form. That allows you to identify a, b, and c. Start with the opposite of b and b squared. The permanent minus 4, and then times the a and the c. And on the bottom, 2 times the a value. So if you do all of this section here, if you type all that in, you get negative 7. And across the bottom, you get 8. And then the I comes from the negative sign under the square root. And that particular answer can't be simplified. So we'll pick up on the next examples here in a minute, in another video.